welcome, ladies and gentlemen, to this Additive Manufacturing Forum Webcast 2020. Ladies and gentlemen, welcome to everyone of you around the world. I am very excited to host this event for you today. We have great panelists to join us later on who will give keynotes on their speeches, which they would have done at the Additive Manufacturing Forum Berlin, beginning of March. Ladies and gentlemen, this picture needs no further explanation. Of course, it is on everybody's mind. As you can see, we're making the best of the situation using very exciting digital tools to replace current face-to-face meetings. Ladies and gentlemen, our panelists today are Marie Langer, who is the CEO of EOS GmbH. We have Michael Kutschmick, who's the head of additive manufacturing at Siemens Mobility Services. And we have Dr. Carsten Heuser, who is the VP of additive manufacturing at Siemens Digital Industries. Ladies and gentlemen, quick information about this webcast to you. Don't worry if you have any technical problems. We will record this entire session and we will make it available to you afterwards. Also, beneath the slides that you will see, you will have a chat symbol where you can place questions to the panelists and we will address them in a Q&A session afterwards. If we don't get to your questions, don't worry, we will take up all these questions and provide them with answers to you in the aftermath of this session. Now I would say, let's get right into it. I am Nicolas Witter. I am working at Siemens Digital Industries in the field of additive manufacturing. And like I just explained, our panelists are with us today. Carsten Heuser is in the studio with us, so he seems to be fine. Let's quickly look into how Michael Kutschmick is doing. Michael, can you hear me well? Where do we find you? How are you dealing with the current situation?
Hello, Nicolas. I can see you and can hear you. I'm fine. I'm here in Erlangen Süd in the Center of Competence, and I'm happy that we can do this webcast today.
Great to hear you. Welcome to you. Now let's look to Marie Langer. Marie, how about you? Can you? Welcome. I can see you. Hello.
Hello.
How are you
I'm here.
How's your team?
Yeah, thank you. I'm very happy to participate in this webinar, and yeah, it feels a little bit like home office. Actually, I'm in the office in Kreiling, but there's no one else. So yeah, I'm really excited to have the panel now and to listen to the presentations of the other members. So yeah, thank you for having me.
Perfect. Marie, the digital value chain is your topic. Since we're already talking, just go ahead. The stage is yours. Thank you.
Of course, yeah, thank you very much. So yeah, today I want to talk to you about how additive manufacturing is actually disrupting conventional manufacturing through digitalization. And the most disruptive part and aspect is actually not the printers itself, it's the value we can create together with partners for our customers along the whole digital value chain, starting with the digital thread, going to a digital twin, and then using digital inventory. So there are great benefits that we can leverage actually for our customers here. It's freedom of design, speed to market, optimized production, secure supply chain, and then a controlled phase out. And I actually want to share some examples with you for specific benefits, freedom of design, speed to market, and secure supply chain right now with you. So talking about freedom of design, I think you all know how additive manufacturing works. I don't need to go into detail there. What excites me the most here is actually that we start at the beginning, actually, with the question, how do you design a part in a way it can have the best performance and the best fulfill the criteria you actually want to fulfill to have the part. And with additive, we are able to use bionic designs and are actually also able to design parts in a completely different way than conventionally possible. So one example actually is parts of in a cooling fan. They're actually, normally you need to have over 70 parts assembled to have this fan then working in a cooling system. And with additive, we were able to only build that in one part. And I think you can imagine what this means for reducing in cost that you have through assembly, and also reduction of resources in general, and also material that you waste. Another great example for freedom of design is actually, I have them here in my hands, are some like insoles that we're working on together with our partner Atrax in the US, and we were developing that for 2 years. Actually, the philosophy behind that is that no feet are alike. So actually also what we have a lot with shoes, that we have shoes that are the same, but actually our 2 feet are not the same. So with additive, actually the great scanning system and solution that Atrax was offering, we were able to produce these insoles and making sure, and maybe you can see that here, that every part of the insole has a different thickness or fitting to the criteria and the pressure map actually that the scanner shows us. So making sure that it fits the best the feet and supports the feet the best way possible. So I'm really excited about this project because we can see here what kind of great product innovations we actually can realize with additive. So another point that I want to talk about is speed to market. And there's an example, I also have it here. It's developed by our customer Hexer. We were supporting with that. And what you can see is not only that you can customize it, what is actually something, a tendency that we see and the demand that we see in the market right now. And it's through a digital app. So you have it on your iPhone, you can scan your head, and within 1 minute, then you have your file that is fitting perfectly to your shape. And what actually was realized here, that also when the way this interior was designed, is that when talking about the pressure that the bikers could get when they fall down is much better distributed than conventionally. So it's a much safer product. And talking about speed to market is that here the product development time could actually be reduced from 2 years to 3 months, what I think is massive. And then when you talk also about distributed manufacturing and on-demand manufacturing, that actually is a very important aspect in keeping up the speed. I think that's a great example that I actually want to share with you. So a third benefit that we see, and an example I wanted to dig into, is to secure the supply chain. And what we see also now with Corona is that that's actually a big issue. And the capabilities that additive is offering now with also decentralized production is actually very, very important right now in these times. So what you can realize in using digitalization actually, and the digital twin and the digital inventory, is that you lower your logistic costs because you don't have to store all your spare parts in your warehouse. And so you reduce your inventory that you have to have in-house. And actually you secure your supply chain because through decentralized manufacturing, you can print anywhere and any time when you need it. So one topic that is really dear to my heart as well, and actually that's why we added a sixth benefit here, is that we also can leverage with additive great ecological impact in the world, and actually improve the way we use resources and the way we manufacture and produce parts. So what we actually see is that with additive, you can reduce the energy consumption, as I digged into that already. When you realize decentralized production, you don't have to ship the stuff around, and also some parts, especially for airplanes or in other areas of mobility, we also see that you can lower the carbon footprint because of the lightweight and components we can realize through the bionic designs. And so we're positioning this much more now under the wording responsible manufacturing. And I just want to invite all of you in the community to contribute to that, because we only can do that together. So that was it from me. I made it short. That was what I wanted to share with you now in a nutshell, these elements. And I want to hand over now actually to Michael from Siemens Mobility, who will share some thoughts and give us some input about spare part production and connectivity. So go ahead, Michael.
So thank you, Marie. It's really great that EOS has provided additive manufacturing machines and materials for 30 years. Without the additive manufacturing equipment industry, we as a user would not be in the situation as we are now. But there's still development necessary to change from prototyping and a manual process to industrial serial production with highest grade of automation. Before I will talk about additive manufacturing within Siemens Mobility, I would like to explain the products and the service offered toward our customers. The portfolio of Siemens Mobility is almost everything around the public transportation. Siemens Mobility is designing, manufacturing, and delivering vehicles like high-speed and commuter trains, locomotives and passenger coaches, as well as metro and light rail vehicles. Beside this, our portfolio includes the necessary infrastructure and traffic control systems. As sometimes customers requesting the complete system, for example, new metro lines, we have also turnkey projects in our portfolio. But at the end, our customer needs highest availability of all the systems. And if you have a train which is not in operation, you lose a lot of money. Therefore, we have our service business, including maintenance and refurbishment, as well as spare part supply. To ensure the availability of the vehicles and the infrastructure, Siemens Mobility has developed this quick and reliable spare part supply called Easy Spares Next Generation. This is a combination of some of our innovative service products, like diagnosis by data analysis, the spare part identification by our Easy Spares ID application, where you can identify the part just by taking a photo, and our spare part ordering by our online shop Easy Spare Marketplace. Let's have a look how it works.
Time. It runs our world. It's fundamental to our daily lives, and we prize it highly, both in our private lives and in business. Because when we save time, we create efficiency. Easy Spares Next Generation operates on that basic principle. Because Easy Spares Next Generation now introduces to rail operations what we've already been enjoying in our everyday lives online. Extremely fast, simple, and reliable delivery. Using Easy Spares Idea, our customers can identify required spare parts within 10 seconds. Order them online in 3 minutes through Easy Spares Marketplace, powered by RailMall, and receive them within 24 hours. That's how our customers not only save time, but also lower their costs and guarantee their passengers optimum availability.
Siemens, ingenuity for life.
Within the Easy Spare Marketplace, you can order your spare parts from your physical stock within 24 hours, or if not available, from our virtual stock printed on demand. But why do we use additive manufacturing for spare part supply, as we have all relevant spares on our physical stock? In rail industry, we have a lot of different vehicles all over the world with low and medium quantities. They are in operation for 30 to 60 years. Some spare parts are required after 15 or 30 years for the first time. If you try to order this part from your previous supplier, or if you want to restart the production in your own facilities, you will most likely have problems like one-time costs or minimum order quantities. Siemens Mobility identified additive manufacturing as one of the first rolling stock providers as a solution for print on demand and manufacturing close to the location of demand, instead of manufacturing thousands of parts and taking the scrap risk. This technology was used before mostly for prototyping. To use it in a conservative and strictly regulated rail business, you have to solve a lot of topics before. This is what Siemens Mobility has done since 2013. Before we can use additive manufacturing, we have to help our customers to identify which parts could be printed, which part is printable with the existing machines and materials, and if the required material properties can be achieved, or better, can be ensured. If a part can be printed, you have to answer the question if the part should be printed. Does it make sense from a commercial perspective to print a part instead of a conventional manufacturing method? The understanding of the cost structure of the complete maintenance and supply chain is important. The demand always comes from our customers. We offer our internal and our external customer training and consulting, especially for additive manufacturing in the maintenance area. Only a trained customer can quickly identify if a part is printable or not. After the parts are identified, we concentrate on the complete engineering process. The manufacturing happens on qualified machines and the processes. Siemens Mobility has respective rail engineering know-how combined with additive manufacturing knowledge. In rail business, we have to fulfill certain requirements regarding fire protection, mechanical material properties, and for example, on the environmental resistance on the coating of a printed part. Siemens Mobility is able to provide the necessary documentation for the authorities for their approval. So what are the general use cases which Siemens Mobility has realized during the last 6 years? How did we identify thousands of parts in a strictly regulated industry with a very high price pressure? We have started with service application due to the fact that we have this high variety of required spare parts with very low volumes over 30 to 60 years. But we found out that the performance of our products can be improved significantly by using this technology with less design restriction than conventional manufacturing methods. Now we support our customers in their daily service business, and we use additive manufacturing for our new products. The serial parts in our new products are already ready for printing in later service cases. That's a logical way forward. As we have identified a wide application, we have to design these 30 or 60-year-old parts according to the newest rules and regulations. But we can also implement the wishes of our customer. They have already used these parts over this very long time. Maybe they would like to optimize the part according to their maintenance or end customer needs. We do that in a customer co-creation process. Once the customer requests the parts by our EasyPlan marketplace, we get in direct contact with them. We optimize the part according to their specific needs and to rail specific regulations. After printing a necessary approval process, which will be determined by Siemens Mobility, the part can be ordered on demand out of our customer-specific virtual stock. The customer can do that to have to put these parts not anymore in the physical stock, so that they can reduce the capital cost, the storage area, and their scrapping risk. In the following video, you can see some examples, unfortunately in German, but with English subtitles. Als Siemens Mobility Services bieten wir unseren Kunden intelligente und effiziente Ersatzteillösungen im Schienenverkehr an.
Wir müssen eine hohe Verfügbarkeit unserer Fahrzeuge sicherstellen und deshalb ist es uns wichtig, dass wir auch die Ersatzteile verfügbar haben. Wir können es uns nicht leisten, eine Bahn abzustellen, nur weil ein Ersatzteil fällt. Die Siemens Mobility ist für uns ein langfristiger, regionaler Partner, mit dem wir seit 2003 sehr intensiv zusammenarbeiten. Die Firma Siemens macht jetzt die additive Fertigung und mit dieser Fertigungsmethode sehen wir klar die Vorteile, dass man kurze Lieferzeiten hat, dass man auch Teile konstruktiv weiterentwickeln kann.
Die Ersatzteilbestellung läuft relativ einfach. Man geht in die Railmall, eine Online-Bestellmöglichkeit und sucht sich sein Teil aus anhand der vorhandenen Nummer und bestellt es per Mausklick.
Unsere Kunden haben dadurch den Vorteil, dass sie ihre Lagerbestände auf ein absolutes Minimum reduzieren können.
Früher in der Vergangenheit war es so, wir haben also eine Mindestmenge in GfK gefertigt, die dann auch konstruktiv abgeschlossen war. Heute gibt es Bedürfnisse, an konstruktiv vorhandenen Komponenten Änderungen vorzunehmen und da hilft uns genau die 3D-Drucktechnologie.
Die erste Anfrage der SWU bezog sich auf die Integration von 3 zusätzlichen Bedienelementen in die Armlehne. Im Laufe unserer Arbeit hat sich gezeigt, dass weiteres Verbesserungspotenzial besteht und so wurde schlussendlich die komplette Neuentwicklung der Armlehne von der SWU an uns beauftragt.
Die Schürze ist ein gutes Beispiel dafür. Die ist dreigeteilt und braucht nur noch segmentweise getauscht werden. Also eine gute Entwicklung. Mit der SWU sind wir seit sehr vielen Jahren eng miteinander verbunden. Wir arbeiten gemeinsam daran, die Fahrzeugverfügbarkeit möglichst hoch zu halten.
Bei der additiven Fertigung ist man natürlich sehr frei, kann vom Kunden viele Anforderungen aufnehmen. Wir hatten auch sehr viele Wünsche bei den Teilen, die wir bei uns verbaut hatten. Und die wurden von Siemens alle umgesetzt und sind in diesen Teilen jetzt eingearbeitet.
As the installed base of Siemens Mobility is spread all over the world, we started to set up a worldwide printer network. This network consists of people with well engineering and additive manufacturing know-how, as well as printing capacities in our regions. As you can see, we have already locations in Germany, UK, Russia, US, France, Spain, Switzerland, and Austria. The journey has already started and will be continued. The important point is that we have established qualified business, engineering, and manufacturing processes, which are certified according to all rail industry-specific regulations. These processes are the basis for our worldwide locations, which are in regular exchange with our Center of Competence here in Erlangen. The Center of Competence can check the status and the setup of the network printers online and review the results of the defined quality tests. Also, all engineering work results will be finally checked by our experts here in the Center of Competence. Wherever a spare part will be printed by Siemens Mobility, it will be the same high level of quality. But additive manufacturing is only one part of our digital service portfolio, as you can see now in the next video.
What does it take to be the best service partner for railway operators? Operational streamlining, inspections, and maintenance all under one roof. Paperless, our fully digital depot is a world first. Using our open ecosystem Railagent, we combine the latest software, technologies, and processes to create a network that works in perfect harmony. The ability to predict and eliminate errors before they occur. Thanks to our servicing experts and our skills in data analysis. Everything prepared and in place. That's why your train is back on track quickly and on time. Every day and every night. For 100% system availability. Helping your trains exceed your customers' expectations.
So as you can see, it's only a small part of our digital services, but the current entire process chain, including the quality assurance process, is very complex for additive manufacturing in comparison to conventional manufacturing. And maybe you can imagine the required efforts to manage the process with tools which are either not available or working with different data formats. The result is a huge manual effort to hand over data without loss of data quality. This intensive work is not appropriate for a depot where the employees just want to print a spare part and do not want to be specialists for additive manufacturing. Carsten, perhaps you could show us now how Siemens Digital Industries can help the users and the machine providers with these challenges.
Yes, thank you, Michael, and thank you to Marie. Really impressive results you have reported here, and a welcome as well from my side to the more than 500 people being all over the globe live in this webcast. I'm really proud and would like to show you how these digital solutions, physical solutions can be connected in a full end-to-end workflow and bringing topics together. We in Siemens Digital Industries embrace this as a digital enterprise portfolio, which consists out of a digital twin of a product, a digital twin of a production, and then the real production where our automation comes into play. And the cool thing and the smart thing here is on industrialization. All this flow needs to be seamlessly connected to industrialize additive manufacturing. And it's embedded in the collaboration platform. And for sure, industrial security is an important topic. Let's dive into some of the portfolio elements inside of this and start with the digital twin of the product. Here you see some examples which are all in one workflow, in one Siemens software system installed. It starts with convergent modeling. It starts with leveraging automated design exploration by different kind of tools. And all this is combined, and you do not need to leave a software solution. And this is a digital twin of the product. And I will give you some examples pretty later in my talk. But if you dive in this digital twin, then one level deeper, then there's a material. And we heard already from Marie on the material, and Michael talked that the process chain needs to be under control. And therefore you see two examples here that we now, next to the most powerful digital twin of the product, we now having a digital twin of the material. Digital material can be designed and optimized by software features. Just recently, we acquired a company, Multimechanics, making this possible, that you can optimize the actual material properties before you print and then learn at the end. Furthermore, by knowing the material properties, you are able to design experiments with specific lattice, and any kind of structure will offer you a full new spread of kind of designs in terms of material. So this makes a digital twin of the product, but then the next situation is people very often still try to print and find out it's not working. And a lot of power goes in Siemens inside of the development of tools for the macro and the meso level defects through simulation prediction. Here you see the examples. Pretty easy, a tool which is from Atlas 3D. We acquired end of last year, Sonata. A very easy tool where you can combine now deformation with support structures. This is a cloud-based tool. It will be part of our AM network later in the year. And it's a pretty easy to use tool. And in the middle, you see another prediction tool where layer by layer, we can in the meantime predict the thermal behavior in a selective laser melting process. And even further, you can now start not only to predict, you can compensate by the software to have a first-time right printing. And another step forward, at Formnext, we presented for the first time that even another tool is coming up on the horizon. And there we can optimize the tool path to eliminate localized defects before you start the printing. What is the benefit of this? This lowers at the end the production costs because it's first time right printing. And with this, you can really simulate the process before you start printing. Now, if we are now finished with the digital twin of the production, the process, the next step is how to plan, run, and monitor an efficient entire additive manufacturing factory. One aspect is on the digital layer. For sure, you need to have a software to plan and execute when to do which job on which machine, from configuring the machine to getting worker instructions directly at the machine. It's paperless, and we have proven this in different kind of facilities already, to managing the processes, traceability, tracking of all your powder, recycling the powder. So this makes the digital backbone to plan and execute the factory on a digital layer. But then the next step is, as well on the shop floor, you need to industrialize the processes. On the one hand side, we are proud to work with a lot of different machine companies. Here you see we are proud to work with EOS together to provide automation inside for the machine, for drives, controls, and any other equipment there, to really improve uptime and optimize the machine itself inside. But beyond, you all are experts in the additive community. You know a lot of post-processing steps needs to be undertaken. And here we are working on automating the additive process by combining software and hardware automation. For example, you see a snapshot here from Solocon of a depowdering station, which is more intelligent, adding another value by more productivity because you can be faster in your production. And then last but not least, we're moving into planning full-fledged additive manufacturing factories. We have a planning team of consultants working together with our machine partner to plan digitally with our tools complete additive manufacturing factories. The input parameter are the machine, the costs, the requirements, and the output parameter is the quantity of the production, the throughput, the stuffing, and everything like that to really plan and operate the factories very efficiently. But last but not least, when you install the factory, you need to be sure what happens inside. And there, once more, you have two layers. You want to know at all times, how is my machine doing? How are all the machines connected from the different entities here? And it's about machine monitoring. With our cloud-based MindSphere solutions or Mandix as a platform here for low-code coding, we have proven in the meantime that you can connect and get a system with all different kinds of machines in one dashboard to really manage and improve your efficiency of the overall equipment in your factory. Already a few and leading players are connected in this system and are working. The next step is how to optimize the cooling of an ECE train. This is now a concrete example, and I want to send my regards to Helmut Zein to Hamburg. Helmut is heading the team here and worked for the RM Forum in the regard to make this use case happen. And this is done as well in collaboration with Michael from the Siemens Mobility tool. Let's consider an ICE, a high-speed train from Siemens Mobility, and you see some geometries here. And the red part on the right-hand side, you see here, this is produced out of 11 different parts you need to assemble and put together. And the space is very limited in an high-speed train for the purpose to have an optimized climate system. And the question to the team was, how would we be able to use now the toolbox I just showed you to optimize this process and this part? Let's dig into this in examples. First, our experts took the 11 parts and then they throw the 11 parts in our software and transferred it in one software tool, which is part of our SimCenter Star CCM. And now we see in a movie here coming up, how does it look like that our Star CCM now becomes more or less the designer. Though the software is now starting to iterate in many, many steps. And here at the end, it was more than 100 to 200 iterations to optimize the design to the perfect flow and to the least pressure drop along the area. By that, you come up with a crucial fancy design normally, which is optimized for the flow. But in the next slide, you will see here, it's not always the best in terms of that you have optimized for any kind of design. Now you have the benefit that you stay in one software suite. And once more, we throw it now into our software and we start to optimize it. In the video, you see how now we can start to optimize areas where probably the simulation, the morphology have given us something we have difficulties in the later printing. So you can paint it, or you can even optimize and automate this process here to really now change, for example, parts of this geometry with your classical kind of well-known CAD tools, and you can start to optimize it. You can use and provide any kind of the classical tools as well further to adapt and design further geometries into this design. This saves you a lot of time through fast and efficient workflow, and you reduce the need for any physical prototype at the end because you can optimize this part already in this software. If we go to our next slide here, then once more, you can go back in a physical test of the full design by using it in a star CCM simulation, as you see on the picture here. And there's a little small graph. On the y-axis is the pressure drop from a very high number. And on the right-hand side, you see after 1,400 iterations, how the software managed to reduce the pressure drop. And what is it? It's at the end a better air condition in your high-speed train. And after already 150 to 200 iterations, we are already on a level which is more than double the pressure improvement than we've had initially in the design. So let's get further. Now we have a digital twin of the product finished, accomplished. Now the question is this printable? How to validate the manufacturing? Let's go once more into our software suite, where we now start to integrate and look into the production. One first question you would have is a part really good positioned? What are the wall thickness? Do I have some checkers who can tell me if there are some inner circles in a room where I would have problems while printing? So in this part, all these checkers are already in our software. So you need just to use it by the software and start now to optimize by these design checkers. If you have some inner area, if you have some overhang which will not be printed. So a lot of intelligence from the printers are already incorporated. And once more, if you find out something here to change, you just go back in the digital twin of the product and you have it on a mouse click that you can change it here. Here you see some red marks. These are actually the design checker where you can really now improve this process. So this is one thing. And the next thing is now how to integrate the printer interfaces. And this is, I will explain here on the next slide, that we have connections in the meantime through all the materialized connectors. We have direct printing connectors like EOS Print. As well, with Cura, we have connections to any kind of other printer like Ultimaker in the meantime. And once more, what do you want to have is you want to have a view into the printer before you start printing. And in the next video, what you will see here is that we are having now a virtual build chamber of such a printer. And in the printer, you upload now the part, and then you can start to optimize this part, but we have algorithms already. These algorithms will help you to orient the part based on what kind of printer you will select. And depending on that, you can optimize what kind of support structures you really want to use. And I already mentioned in the future with Sonata, this is as well on a cloud system, making it very, very easy and automated. Once more coming to real improved flow here. And here you see now how these support structures are generated while I talk about this. And here, this was done on an FDM printer later on, could be done on an SLM or any kind of printer. All these interfaces are already connected. So what is the result? If we look into the digital enterprise slide once more on the next slide here, you will see the result. On the left-hand side, we started initially with 11 parts and ended up with a much improved part, which is printed out of one piece. Then we run through the full cycle of the digital twin of the product, the digital twin of production. We looked into real production, and here at the end, we have a 26% flow improvement process here by this new cooling. And I am already looking forward to see it in the next high-speed trains from Siemens Mobility, giving you at the end better air conditioning. So as Michael already explained, what is the rationale of this toolkit, as I just mentioned? It's about tightly control the entire process chain, digital and real. It's about ideally designing parts. It's about using cost-efficient measures on low-cost parts. It's about certification. It's about automating and auditing the full production line. This is what we stand for, what we're working on in co-creation with our partner on the machine system side as well on the end customer side. And that's what I want to show you in the regard. And therefore, I think, Nicholas, I would like to hand over to you. Thank you for the attention.
Perfect. So I hope you can all see me well. In case you are looking for more information, you find links here where you can find to all these different presentations, much more information and get informed about all your questions and so on. In the meantime, we had some really good questions from the panel. Maybe to start with you, Carsten. I've read on social media and on different places about different initiatives in the current COVID-19 crisis. For instance, Volkswagen is doing something and so on. What is Siemens doing in light of this situation? Are there any examples?
Yeah, that's a pretty good question. You see a lot of action going on there. I'm very proud that we can tell that by yesterday, the team of Robert Meschel from the AM network have made it possible to open our additive manufacturing platform, the AM network, for the external world. And this is free of charge, and we will have an announcement later today. And everybody of you being a service provider or being somebody who can design and engineer for additive manufacturing, or somebody who needs something, even up to hospitals and doctors, would now be able to connect to the additive manufacturing network. For sure, we in Siemens have a lot of printers. We have experts in designing. So we are working on onboarding all these colleagues. And I can just invite all the different service providers listening to this webcast here. Go to our AM network site. You find it on Google and then get connected. By that, I think we can do a lot of stuff in helping getting cases here for supply chain critical parts in the current COVID situation. But I guess, giving back the question to Marie, I guess at EOS, this is a topic as well. How do you deal with these COVID actions right now?
Yeah, of course, it's a great topic for us as we see that 3D printing and the potential we have in additive manufacturing actually can help a lot right now in securing the supply chain that we need and offering the right products now to the patients and making helping the doctors to be more safe in dealing with that, as some examples. So actually we have a global team at EOS that now in US and in here Europe, also in Asia, is working together on helping our customers, the service providers, and supporting these kind of initiatives. We have some great partnerships with some of our material suppliers where we give material for free to our service providers. We also offer production capabilities and, of course, our experience in designing parts from the Additive Minds Medical Consulting Group. So these are just like a few things that we're doing, and I just want to say that EOS cares, and we're happy to support every one of you in the network with our expertise to do so. A lot of our employees wrote me personally that they want to get involved. So right now we kind of trying to push every initiative that can help further right now.
Very interesting. Thank you. Maybe to Michael as well. Michael, you have been at Mobility Goes Additive just recently. What can you report back from there?
Yeah, also within Siemens, within Mobility Goes Additive and Medical Goes Additive, it's a common workforce. There are 200 different companies willing to support in this COVID times with engineering, with printing, with materials and so on. But beside this, we are also member or part of the AM network, what Carsten mentioned. And the third point is that we already started to print some specific parts in Russia and in Germany for our local people, and we will start the same in UK during the next days. So we are willing to support, and Medical and Mobility Goes Additive is waiting for real requests on parts.
Okay. Another question would be, Marie, you talked about it, and also Carsten, in your direction. I've heard from the Hannover Fair pre-press conference, and I've seen the helmet picture and heard about EOS and Siemens and Hexa doing something. What's that all about? Maybe explain.
Yeah, Marie already showed, and there's not one helmet, there's another helmet. I have one here as well. And Marie already showed us and explained the advantage, and therefore I want to send some regards and greetings to Jamie and the Hexa company. I hope you're all doing well in London. And it's great to collaborate with you, because the target is how to make it possible, instead of some thousands, to make 20, 50,000 of these helmets. And how to scale it, how to industrialize it, and how to reduce costs. On one hand side, you can do a lot, as I talked on the digital thread here, with a better automated workflow. In this regard, for sure, we have seen and heard already from Marie that colleagues are starting now having an iPhone app as we speak launched. So this will now open up the Hexa individualized helmet for everybody in the world. So there's a need to scale it. And at the other side, we are helping on now building first factory concepts. And there we are teamed up with Hexa and EOS as well, and other companies, how to build the most compelling and most productive concept. And we are working with the newest P system from EOS. Marie, if you want to say something on this side to really industrialize and come to a lot of different helmets in the future.
Yeah, so I think you all know our P5 system. So we're decided that we will use that for this case and actually work with that internally to make sure that we leverage the potentials of this system in the best way that is actually made for full production and serial production, and also learn in the cycle and adapt the things that we have problems with right now, then to be able then to offer that also to other customers.
And I can tell you the experience is awesome. So I was in London, I think it was in January or somewhere. It took some minutes to scan my head, and at the end, in less than 4 weeks, I received this nice helmet, which is even much safer than any helmet. And I can tell you, it's incredible. You cannot feel it, but it's fitting perfect. And this is where additive can really play the important role here. A lot of stuff, orthesis, eyewear, and different kind of individualized products will be made possible by means of industrial additive manufacturing in the future.
What people don't see, maybe you're also wearing 3D printed shoes right now. So really from head to toe, 3D printed all the way. Very good. We have a lot of questions, so let's get to some also from the chat, some more. There's a question to Marie and Carsten. How do you see the market evolving by giving access to the additive manufacturing landscape to people in demand who have experiences in using CAD, for instance? And where do you see the challenges for the industry in that case?
Marie, you want to start?
Yeah, so I think from a software side, then that's also would be interesting to hear your thoughts, Carsten. So in general, did I understand the question right? That it's about how we see the industry in general developing and with the issues we see still?
That's how I take it, yes.
Yeah, okay. Yeah, so actually what we see is that we have much more use cases popping up that actually really show that additive manufacturing is working, and that you also, from a financial point of view, that it makes sense. But of course, there's some, like the cost per part is still something where we have to work on, reducing the material cost and also leveraging some of the potentials that you can do with large production, as Carsten already said, much more. So what I actually think is that we also have to work much more on leveraging the potentials we have with the freedom of design and actually the materials and the probabilities that we can influence through that process we have in that manner, and that will open up completely new applications. So it will be there will be product innovations that we also see already with the insoles or the helmets and these kind of things. So products that we actually cannot produce conventionally. And this will, of course, take time. And we work a lot at EOS to prove that our machine are having stability and the right quality that actually our customers need. And yeah, maybe from like the software side, Carsten, you wanna add some thoughts.
Yeah, thank you, Marie. Yeah, it's about the design tools. In the past 20, 30 years, our engineers are socialized with classical CAD/CAM software, and it's for sure it's a full disruptive way of designing parts. If you now leave the job to a kind of fluid dynamics tool, but this will make the breakthrough for additive. I'm pretty sure in many areas. If you just print the same part you can do by any kind of other technology, this is nice in terms of availability. This is great in terms of a lot of different applications, tooling. You are still having huge value, but the really breakthrough in the market is that people start now to really rethink from these morphological bionical structures, and this will unlever a lot of different applications in mass market, in automotive, aerospace, and as well other technology, and healthcare is as well one technology. And the other area is what we discussed about the individualization, where software chains need to be there. And we see it with the Hexa case. It's a pretty easy to use software. If anybody sitting at home can scan its head, upload it, and then 4 weeks later you can get your product. You don't need to be a design expert to do that. And this is what we try to help with the AM network, with other tools, that a certain intelligence for the design is just automated and done in the software tools, and you need to operate it, and then it's much easier, and this will leverage the market in the future for additive manufacturing.
And this will enable great mass customization. That's very exciting. We have another very important question. Maybe everybody has a different or its own exciting take on it. Do you think a kind of certification or documentation for each printed part is helping to get even more acceptance or trust to additive manufacturing parts, maybe into the round?
Yeah, perhaps certification. How do you deal with certification in mobility, Michael?
Good point, yeah.
Yeah, I would say this is different in each industry. We for mobility, we have to ensure that the material properties are the same like the material before or like it is designed. And this is a very difficult point because you have to put some parts, some test parts inside of the build chamber. Then you lose a lot of money and you test many parts. The best way is to have a process control during the manufacturing and get all this data and get an approval on the material properties. This is what is important for us to convince the authorities for approval of the part.
Yeah, maybe also to add a thought that is not only going now into the direction of certification. Of course, that's a very important aspect. I think it's also we have to look a little bit like from the psychological side. So, because in the end, what we do is we disrupt an industry or a lot of industries. So what we're doing is actually change management. So people need to adapt to change and be more open to change, and also getting more open up their structures within the organization to make that work. So and what I actually think is a great example is Dimension. I think you all know of that. That's one startup in our ecosystem And actually what they or actually achieved to do is color parts in the polymer area. And that unlocked actually the whole consumer goods industry, because that wasn't possible before. And now it was actually just more attractive because you can color parts, because you want to have like a specific look. And I know that's just like a small aspect. And Michael, you referred to some of the important points anyhow. But I just also wanted to add that I think we really need to be aware that we're driving massive change here. And for that, we also need to think about how to innovate and like how to bring in innovations that maybe can also help people and industries to adapt better.
Yes. So maybe we have many questions. They keep coming in. It's very interesting ones. I'll try to select a little bit to be able to deal with them. Then there's a question. I don't know if we can say anything about this. Has someone picked up the call from the EU for ventilators mask on being additively printed? Is there anything that can be said about this?
We massively discussed it, and as well, Michael, they have discussed it in the round of Medical Goes Additive there, and we offered already our approaches. However, we need to be sure whatever we do and there complies to what is for medical reasons really suitable. How can we produce with our machines for different kind of parts? There are great material or service provider out there already doing a lot of medical stuff. They already working into this. We are in contact with Volkswagen, with Daimler, Task Force and the others, and discussing on a daily basis if we can help. And with the AM network, we can actually now connect hospitals with these blockage and these medical service provider to make it happen. And I think EOS has as well a medical group. They're looking into this topic for medical produced parts as well, or?
Yes, we do that. And actually at the beginning, it was really challenging because there were so many requests that we got, and we kind of needed to start to sort them and to understand who's working on that already in our network and how can we make sure that everyone is contributing the right thing to push that further. But yeah, we of course got all of the requests, and we are working heavily on doing our part in making that happen. One of the things was also free materials that we offered, and one other thing is also Additive Minds Consulting, as I referred to that already, and making sure that also the companies who want to use now production sites to help here can do that more efficiently.
Perfect. The rest of questions you mentioned will be answered on social media.
There are important past questions. We'll get to them. Just one more thing. Thank you for the open platform. This is just an example. So I think all the matters are being appreciated highly from the community as well that are being taken in light of the current situation. Ladies and gentlemen, unfortunately, we are right now out of time. The questions will be dealt with and then forwarded. Thank you so much for everybody's participation. Thank you to the panelists and so on for your presentations and your keynotes. I would say everybody stay safe, maintain social distance, but also stay connected with each other virtually and keep printing. Thank you and bye.
Yeah, and get the product.
Have a good time.
Bye. Bye.
The AM Experience Center is in operation for 1.5 years. And so far we've had roughly 4,000 visitors coming from a lot of different countries on the world. With a team of technology experts running the different kind of additive manufacturing technologies, we have more than 50 portfolio elements of the digital enterprise solution installed live.
It's very special that we have machines from different machine builders from different technology. For material extrusion, we have a robot here from Comau. From EOS, we have a powder bed machine here. From HP, we have jetting machine, and from DMG Mori, we have for the DED technology also a machine. I'm not sure if anywhere else in the world we have such a comprehensive room where all the different AM technologies are live to be shown in one area. For many customers, this is the first touch point to get to real industrialized additive manufacturing. They go into the room with, let's see what happens in the world. They go out of the room that they say, wow, additive manufacturing, the industrialization is on a level I didn't think about until 2 hours before.
There are customers, they have no idea what additive would mean in the future for their business. So we start to really enlighten and have basic workshops here to find your first approach into this journey of industrial additive manufacturing. But on the other side, we have customers being experts, really experienced in additive manufacturing. But they may struggle with isolated software solutions or non-connected machines. They come here, bring their own ideas, and have extensive workshops discussing which kind of material works in which kind of environment, in which kind of machine. The content we generated here in different aspects can now be tailored and multiplied to different locations in the world. This happens in Chengdu in China. This is under investigation in Singapore. This will happen in US in different kind of locations. So this will grow now into local operations for the different focus areas for additive manufacturing in the world.